Now let's analyze the complexities. First for the recursive solution. So in recursive solution, at each element or at each index, either we are going to choose that item or we are going to exclude that item. And in both the cases, we are performing recursion, right? Either until we reach the knapsack weight limit or until we have included all the items. The worst case would be when we include all the n items in the knapsack, if we look to this time complexity thing. So as we're having two recursive calls to make inside each call, that's why time complexity is 2 raised to power n. We keep performing recursion twice inside each call until we reach to the nth item. So it is having exponential complexity. Now let's see the space complexity. At maximum, there will be n entries inside the stack. Other than that, we're not having anything, right? So the space complexity is order of n. Now let's analyze complexities we will get with a top-down approach. The time complexity will be order of nw, as we will be doing nw number of operations, where n is the number of items and w is the capacity of knapsack. We won't be solving the problems repeatedly, and we know that the total number of unique problems is nw, whose results we are storing in n cross w matrix, right? So the time complexity is order of nw. Now the space complexity, the top-down space complexity will also be order of nw, because we have taken an n cross w matrix to store the values. Now let's analyze the complexity when we choose to go with bottom up. Bottom up will also be having same complexities as top down. In bottom up, we're gonna take nested for loops for n and w. The outer one we are having is for number of items, and then inside this loop we are having a loop for capacities. So the time complexity is order of nw. Now the space complexity. The space complexity in case of bottom up will also be order of nw, because we're gonna take n cross w matrix to store the values.